Hello everyone, welcome to Digital Image Processing class. In this video, we will introduce contrast enhancement. Contrast is the difference in luminance or color that makes an object distinguishable. As you can see, in this example, the text on both sides are identical, where the text on the top is dark gray and the text at the bottom is light gray. The message on the top is easy to read when comparing to the message at the bottom, because the message on the top has better contrast than the message at the bottom. If we change the background on the right from white to black, as you can observe that the message on the right at the bottom is much easier to read when comparing to the message on the top, because it has a better contrast than the message on the top. Comparing all four messages, you can see both messages on the upper left and at the bottom right have high contrast, while the two messages on the upper right and at the bottom left have low contrast. Here, we demonstrate a set of images with different contrast on the top row, and their corresponding histograms at the bottom. As you can see, the three row images from the left to right are low contrast, middle contrast, and high contrast, respectively. If we look at their histograms, we can observe that the pixel intensity distribution of the three images are similar. The difference is that the pixel intensity distribution of the low contrast image is squeezed toward the center, while that of the high contrast image is stretched toward both ends. In order to automatically enhance the contrast of an image, which is also known as auto contrast, our goal is to adjust pixel intensity levels such that all available intensity range is fully covered. For example, as you can observe that in a low contrast image, the pixel intensities as highlighted in red rectangles are not used. If we can stretch the pixel intensity distribution of a low contrast image in A toward both ends, as shown in green and blue lines, we can obtain the pixel intensity distribution in B, representing an image with better contrast. To achieve auto contrast, we can design a mapping function as shown on the screen. The red line on the top represents a low contrast image, where VD and VB are the minima and maxima pixel intensity in low contrast image respectively. VI is any pixel intensity between VD and VB. The green line at the bottom represents an enhanced image, where VL and VH are the minimum and maximum pixel intensity in the enhanced image respectively. Vn is the adjusted pixel intensity level on the basis of Vi. You may consider the red line is an elastic band where Vd and Vb are both ends. Vi can be any point on the elastic band. Assume you pull the elastic band toward both ends. The elastic band will be proportionally stretched as shown in green. The original Vi in red will be the Vn in green. The adjusted pixel intensity Vn in green can be obtained using the formula as shown on the screen, which is derived based on the assumption that the ratio of A to A plus B is the same as the ratio of C to C plus D. According to the given formula, we can design and implement a MATLAB function to perform auto-contrast. As you can see in the given example, we create a MATLAB function named auto-contrast, which takes a low-contrast grid-level image, IMG, as its input, and returns an enhanced image, IME. To fully utilize the entire grid-level spectrum, we set minimum intensity level, VL, to 0, and the maximum intensity level, VH, to 255. Then, we need to look up the minimum intensity level, VD, and the maximum intensity level, VB, and the low contrast image, IMG. Once we obtain the VD and VB, we can use the given formula to map any given pixel intensity Vi in low contrast image to a new pixel intensity level Vn in the enhanced image. To look up the minimum intensity level Vd and the maximum intensity level Vb and the low contrast image IMG, we can use MATLAB functions min and max. It is worth noticing that when applying min and max functions on a matrix, the column minima and the column maxima is returned respectively. Therefore, we need to transform the matrix IMG to a column vector by adding the column symbol in the parentheses so that the min and max can find the smallest and the largest values respectively in the matrix. Now, we can implement the given formula in MATLAB by creating a MATLAB expression as shown on the screen. To this end, we can put everything together. Intuitively, in the auto-contrast function, first, we need to avoid loss of precision when performing mapping. Thus, we need to convert IMG from uint8 data type to double. Second, we can set the VL, VH, VD, and VB accordingly. Third, we need to map each pixel intensity level Vi between VD and VB in low contrast image IMG to Vn, which is the new pixel intensity level in the enhanced image IME. To achieve this, we can create a for loop to perform the conversion. Once the VN is obtained, we can find all pixels with the intensity value Vi in IMG, and based on the locations found, write the adjusted pixel intensity value Vn to the same locations in IME. Once all Vi have been converted to Vn, we need to convert the matrix IME, which holds the enhanced image, to uint8 data type. In fact, we can further simplify our code if we utilize MATLAB matrix operation as shown on the screen.